The second question that we have is a pretty interesting question. We have been given two plates, parallel plates, and there is a uniform electric field created between the two plates. The direction of electric field is from the positive charge to the negative charge, therefore it will be constant electric field E from top to bottom direction. Let this be the y direction and this be the x direction. Now an electron enters the field symmetrically between the two plates with a velocity v0 in the horizontal direction. We need to find out the angle of deviation of the path of electron as it comes out of the field. Now let us analyze the motion of this electron. What will happen to this electron is that it will experience a force in the upward direction due to the electric field. Since the electric field is in the downward direction and the electron has a negative charge, therefore the force will act in the opposite direction of electric field, that is in the upward direction. Due to this constant force in the upward direction, it will start moving in such a path and it will continuously keep moving upwards. So by the time it leaves the plate, its velocity will be at a particular angle with the horizontal. Let us call this angle theta. Let me draw the diagram neatly here. The electron travels in a path and leaves the area of the plates at an angle theta with the horizontal. We need to find, this is the angle of deviation because its initial path was in the horizontal direction. Therefore, the deviation is the angle which the final velocity vector makes with the initial velocity vector, that is angle theta over here. To find out this theta, what we can do is that we can find out the final component of velocity in the x direction and the final component of velocity in the y direction. If we can find these two, we can directly write tan theta is equal to Vy upon Vx, because this resultant vector will be the resultant summation of Vx and Vy by parallelogram law. Therefore, tan theta is equal to Vy by Vx. Now our task is to find out Vy and Vx so that we can find out theta. Now let us take the case for x direction. The force acting on the electron in the x direction is 0. There is no force acting on the electron in the horizontal direction, due to which the acceleration of the electron in the horizontal direction is 0, due to which the velocity in the horizontal direction will not change. Therefore, the horizontal direction velocity remains constant to be equal to v0. Now, for the vertical direction, that is for y direction, we can always analyze the motion in two independent directions. For the y direction, there is a constant force that is equal to E into E, that is equal to the charge on the electron into the electric field. This is a constant force acting on the electron. Therefore, the force constant is equal to, let me write it here, the constant force is E into E. The acceleration will also be constant in the y direction, which can be written as E into E upon mass of electron. This is the mass of electron. Now let us write the equation for the y direction. Initial velocity in y direction was 0. Over here, if the electron had only horizontal component of velocity, it had no velocity in the vertical direction. Acceleration is equal to E into E upon me in the vertically upward direction. Therefore, the final velocity will be equal to, for that we will need time. For the final velocity we will need time, because we intend to use the formula v is equal to u plus at. We will get the time by using the equation in the horizontal direction, because in the horizontal direction it has to travel a distance L in a particular time by the time it gets out. So for the horizontal direction, displacement is equal to L, velocity is equal to v0, therefore the time taken is equal to L upon v0. We need to find out the velocity developed in vertical direction after this time, therefore we write the time is equal to L upon v0. So the final velocity in y direction comes out to be equal to Vy is equal to Uy, that is 0 plus at, that is equal to E upon mass of electron into, this is the mass of electron, into L upon v0. This is the velocity in the y direction. So we get tan theta is equal to Vy upon Vx, that is E, that is the charge on electron, into E, the electric field, into L upon mass of electron, me is the mass of electron, into v0 square. because Vx is also equal to V naught. Therefore, we get the value of tan theta to be equal to this. So the value of theta is equal to tan inverse EL upon mass of electron into V naught square. So our final answer for the angle of deviation of the path of electron as it comes out of the field comes out to be equal to tan inverse EL upon mass of electron into V naught square. The important thing you should have realized in this question is that the motion is independent in the two directions, and we can easily apply the formula for electric field to find out the answer.